Hi, and welcome to a quick demo of the HostHA feature. For the purpose of this demo, we have a pre-set up environment with 4 hosts that are KVM based and they have IPMI enabled. In this demo, we'll see what this feature is all about. We'll go through the infrastructure, we'll go through the list of new APIs and global settings. We'll also see some list of traits that HostHA feature brings in and the transitions. We'll see 3 test cases where we will see the host being degraded, the host being recovered and being fenced on investigations. So before we proceed, I'll briefly explain what the feature is all about and we'll go through some global settings and APIs. So when you go to the infrastructure tab, you can start with the zones tab, and on zones, cluster and host tabs basically will give options to enable or disable this feature. So on the zone tab, for example, you'll see this icon on the right hand side that says disable HA. By default, the features are enabled on the zone and clusters, but they can be disabled on a zone level or a cluster level. Similarly, we go to the cluster and we see a similar button which allows us to disable HA. For the purpose of this demo, the feature has been enabled on zones and cluster. When we go to the host tab, we'll see 4 KVM based hosts that are physical hosts that are all IPMI enabled. So you can see the power state of all these hosts are on. For the purpose of the demo, I have already created 3 virtual machines that are HA enabled and they are running on the physical host 3. So if we click on view instances, we can see the 3 virtual machines running on this host. We can actually go and have a look at the console proxy to verify that these hosts are actually running and these virtual machines are actually running and doing some jobs. Let's go back to the physical host 3. Here we see the IPMI settings are already configured, so it is giving us an option to execute any OOBM operation, change password, enable or disable out of band management feature, or configure the out of band management feature. Here in the middle we see 2 buttons. The first button allows us to configure HA and the other button allows us to enable or it will disable HA if it is enabled. Let's go to the global settings first and see what are the different options that this feature allows us to configure. So we go to global settings and we search for HA. Here we see there are a lot of many new options, new global settings that are part of this feature. This feature comprises of giving us 4 different ways of investigation and performing the fence operation. Just like the VMHA feature, the HostHA feature gives us mechanisms to investigate a malfunctioning host and if necessary either try to recover the host or fence the host, and doing so it can then enable VMHA starts of the virtual machines on new hosts. This feature provides us hypervisor agnostic way of doing these investigations and performing fencing and recovery operations. During the implementation of this feature, we have implemented 2 drivers. One is for KVM that uses the out-of-band management subsystem to use IPMI based recovery and fencing. So let's have a look at the global settings. So in order to perform these investigations, we have these global settings that basically manage the thread pool or the number of operations that can execute by these thread pools. So for example, HA max concurrent activity check operations is the number of operations we can do in that specific thread pool for doing activity checks. Similarly, we have these options for fence operations, health checks and recovery operations. These queues can have some length, so these lengths are determined by the depending amount of tasks that are in the queue. They can be tuned by these global settings: HA max pending activity check operations, and similarly for fence, health and recovery operations. These are global settings, and if they are changed, a restart of management server is necessary. Let's move to some other settings that are global settings, but they can be set on a per cluster basis as well. They are all related to HA specific implementation of the HA provider. The KVM HA activity check ratio failure ratio setting is basically a ratio that is used to determine whether to degrade a resource or recover a resource. When we look at the FSM transition diagram, it will make more sense on how these values can be used to fine tune the feature. Further information is also provided in the documentation. There is a setting for doing health activity check intervals and the maximum number of activity checks that need to be performed before a resource is considered to be degraded or it is tried to be recovered. There are timeout options for performing these activities and operations. For example, there is the activity check timeout, there is the fence timeout, there is the health check timeout, there is the recovery timeout. There's also a setting for the maximum amount of period a resource can stay in the degraded state, which is by the KVM HA degraded max period. There is a setting for the recovery failure threshold, so the amount of time a resource or a host is tried to be recovered before we give up and we will fence the host. By default, the default values will be different. For the purpose of the demo, we have fine-tuned the environment so that the demo could be made to run a little bit faster. Similarly, we have other global settings for the recovery timeout, for the recovery wait period. So once a resource is recovered, this is the amount of time we'll wait before any health checks are run. So let me start by showing you a diagram and explain you what these different checks and operations are and what they actually do. As you can see in the diagram, because of this new feature, there are new host related HA states which are used by this feature to determine and operate. We start with the disabled state. So if we go back to the host, we'll go to infrastructure, we'll go to the physical host number 3 where there are HA virtual machines which are already running. So when I click on the HA tab, I see that HA is not enabled and the HA state is disabled. I can see the same information if I scroll down on the details page. So I see HA state is disabled and I don't have any information on HA provider. I see that the IPMI power state is on. That means the server is running. Let's go back to the diagram. We start in the disabled state. As soon as we'll configure and enable the feature for that host, it will transition into available state. Now it will stay in this state as long as health checks are passing. By health checks, we mean that connectivity from the management server to the CloudStack agent process on the KVM host, that is alright and it is working. So it will stay in the available state as long as these health checks will continue to pass. As soon as a health check failure happens, which can be due to one of several reasons, such as the agent process died, or the host died, or the host became unresponsive, it will transition into suspect state where it will continue to do health checks. When it is in suspect state, it might transition into checking state where activity related checks are performed. By activity checks, with respect to the KVM host, disk related activities are monitored, where the host that is being inspected or investigated, we basically check whether any disk related IO operations were happening on the VM disks. It will go between suspect and checking for a couple of rounds governed by the global setting which was just previously mentioned. After the number of rounds have expired and based on the activity check failure threshold, it might choose to either degrade the host by transitioning from checking to degraded, or it might choose to go to recovery state by transitioning from checking to recovering state. If a host goes to degraded state, that means health checks are failing, but activity checks are not going beyond the activity check failure threshold. So it will continue to be in degraded state for a while as governed by the global setting, and it will transition back to available where it will again try to do health checks and might go back into suspect and checking states. If for a host the activity check failures are above the threshold, then it will go to a recovering state where IPMI based recovery is attempted on KVM hosts. In this specific state, it will try to do a IPMI reboot, where it will go to recovered state after doing that operation and then wait for a while and transition back to available state. where it will continue to do health checks and others. It might be a case that a resource is retried couple of times and it still is not recovered successfully. So when it comes back to recovering state, it will check whether the amount of threshold has been exceeded in order to do the recovery or not. In case the threshold has been exceeded, it will finally try to fence the host, transitioning into the fencing state. Once it is in the fencing state, it will try to do an IPMI power off in case of the KVM host. And once the host is successfully powered off, it will transition into the fence state, and VMHA will kick in, and VMs that are HA enabled, they'll be restarted on new host. Once it is in healthy state, an alert will be sent to the sysadmin, and admins can take suitable action to recover the hosts. The host will also be put into maintenance mode. Once the hosts are manually recovered and the agent process is alive once again and can talk back to the management server, it will go to ineligible state in case health checks started to pass. So let's see these things in action, where we'll see in this demo 3 cases, where we'll see the host going into degraded state, where to simulate that we'll simply stop the CloudStack agent process. Then for recovery, what we'll do is we'll make the host unresponsive, so it is unable to respond to any of the pings from the management server, and it is unable to actually run the virtual machines. In that case, we'll see that after recovery, the host will come back online, and VMs that are HA enabled, they'll be started. Finally, we'll see a case where the agent won't be allowed to start after being unresponsive, and we'll see that it will fence the host, and VMs will be started on other hosts. So let's go back to the demo. For our first demo, we'll first configure and enable HA. To do that, we'll click on the first button that says configure HA. It will give us list of all the HA providers that are available for this specific hypervisor of the type of hypervisor of this host. So we'll select KVM HA provider and click on OK. This is going to configure the settings that are necessary for this host to participate in host HA. So if I click back on HA tab, I see that HA provider is KVM HA provider, and the state is still disabled because we have not yet enabled HA. So let's go back and enable HA for this host. Once it is enabled, if we go back to the HA tab or we scroll, we see that HA state is available. We can see the same information in events tab. So when we click on events, it can actually see a lot of these transitions happening and operations that are done to the specific host. We go back to the host, go back to host 3, and we'll stop the agent process and see if it goes to degraded state. So I'm already inside physical host 3. If I run the status command, I see that the CloudStack agent is indeed running, so let's stop it. So we'll stop the agent process, and as soon as it successfully stops the process, as we can see CloudStack agent is stopped, we'll see HA will start to investigate because the agent process is no longer able to communicate back to the ping request from the management server. So now what will happen is it will go between suspect and checking. As you can see, it was in the suspect state, and now it is performing activity checks in the checking state, and after a while it will determine that disk-based activities are actually working, but health checks failures are only failing. So in that case, it will decide and go to the degraded state. So this time it has transitioned back from checking to suspect and from checking to suspect. So it runs and performs these a number of times. By default, the number of rounds are 10. For the purpose of the demo, we have set it to 5. So now we see that finally, after performing and going through between these states, between suspect, checking, and available, the host has been degraded because of health check failures. So after restarting the Cloud Stack agent, we can see that the HA state has finally gone into available state. In the next section of the demo, we'll see recovery in action, and in order to do that, we will make the host unresponsive, and we'll see that after the suspect checking cycle completes, it will go into recovery mode where an IPMI based reset will be performed. So on host 3, if you click on view instances, we can see the instances are still running here. And in order to make the host unresponsive, we'll execute a command that will cause a panic and make the host unresponsive. So right now we can see the host is responsive. As soon as we execute this command, the host will become unresponsive, Cloud Stack agent will degrade, and will be unable to connect back to the management server. So if we go to the host tab and we refresh, we will eventually see that physical host 3 goes from up to either alert or disconnected state. As soon as, and we see that HA has already detected health check failures, and it has gone and has started doing health and activity checks. If we go to the details, we can see that it is doing health and activity checks here. One thing we can do is we can go to the management server and tail the logs and see HA in action. So for the first round, as soon as the failure is detected, not all the disk-based activity checks may pass. So the host may be put into degraded state for a while, and in the next round of the suspect checking cycle, it will detect that both health and activity check failures are happening, and it will finally recover the state. So looks like it has recovered the host, and HA has been enabled. So we see that HA state is enabled. That means the host was rebooted. So if we break out of this shell anytime soon, we should be able to SSH into the server. We also see that the agent is disconnected. So if we go to the details tab now, and if we refresh, we see that the agent state is now alert. As soon as an IPMI based reset is performed, it continues to stay in the recovered state for a while to give the amount of time needed by the server to reboot and restart the Cloud Stack agent and the KVM host. So now we see that we are able to SSH into the server. So let's do that, and we'll verify the health of the Cloud Stack agent. So we see that agent is running now. So as soon as the HA state goes out of recovered HA state, we'll see that it transitions into available state. So if you go back to our FSM diagram, in the recovering state we started the IPMI based reset and then transition into recovered state. Then we spent some time in the recovered state to allow the management server to connect back to the agent when the host successfully reboots. As soon as that timeout occurs, it will transition to available, where health checks will continue to run, and what we'll see is agents communicate back to the management server, and when in available state, health checks will continue to pass. We also see that while the host was rebooted, the virtual machines running on the host were all HA enabled. So HA related work for the VM has also already kicked in, and all the instances are now in running state again. So if we go back to the host and click on view instances, we see that the instances are again started on the same host, which was just recovered. Depending on the amount of time that was configured, the HA state may continue to be in the recovered mode until that timeout expires. After the recovery wait time period expires, we see that HA state has transitioned back to available. In our next and final part of this demo, we'll see fencing in action. In order to simulate that, we'll make the host unresponsive and make sure that the agent does not start after the reboot. So let's do that. So right now we see that host is in up state, the HA state is available, and we can see some instances that are running on this host that are all HA enabled. So we can see the console also to verify that VMs are actually running. In order to simulate host failures, what we'll do is we will first rename the directory By doing this, it will ensure that after the host is recovered, the agent won't be able to start. The next thing we'll do is we'll make the host unresponsive by again triggering a panic in the kernel. Now when this will happen, it will again try to recover the host. It will recover it a couple of times as per the global setting, and finally it will try to fence the host. So if we go back to our FSM diagram, right now we are in available state. As soon as health checks start to fail, it will go back into suspect and checking. It will continue to do a couple of rounds and finally decide whether to degrade or fence the host, or recover the host. When it tries to recover a couple of times and the threshold for recovery operations are exceeded, it will finally try to fence that host. We can go to the events tab and go to the alerts tab, and we can actually see a couple of things. For example, when the last recovery was attempted, we can see that HA recovery for a specific host in a specific data center was performed. If email and SMTP is configured in the global setting, the same information is also sent via an email. So we go back to our host 3, and we see that it has detected health checks failing, and it has started to do suspect and checking rounds to perform health and activity checks. So if we go back to our management server and we tail the logs, we will see transitioning happening between suspect and checking, and now we see that it has tried to recover the host. After the recovery, we will be able to SSH into the host, but the agent won't be allowed to start. Now in this case, recovery will happen a couple of times. After the threshold for recovery has exceeded, it will try to fence the host. After some time, we see in the logs that the recovery was attempted once again, and in the next round, when it tried to recover, it found that the number of recovery attempts has exceeded the threshold, because of which the HA state transitioned from fencing to fenced. During this operation, IPMI based power off is sent to the host. As soon as we do that, we see that host HA has fenced the host. If we go to the details, we refresh, we see the state is down and power is actually off because IPMI power off was successful. If you go to the instances, we see none of the instances are on this host now. If you see the logs, we see as soon as the host is fenced, HA related tasks are performed and HA enabled VMs are restarted on other hosts. So we see investigations being going on and HA related jobs being scheduled. And we see that HA related work has successfully completed. So if you go to the instances tab, we see that these instances are now running on different hosts. So let's pick one of them. So for example, VM1 is now running on a different host, host 4. If you click on the console, we can click this and verify that the VMs are actually running on a different host now. If you go back to the infrastructure page, go to the host, we see that this specific host is now powered off and the agent state is down. This concludes the demo of fencing of the host in case of a failure.